In this class, we're going to consider the equation of straight lines. So I would say if you've not already watched the video on the introduction to straight lines and taken the class on the gradient of straight lines, then maybe check those out first. Those are kind of important building blocks to get maybe to this point, or just follow along here and then check those one out later to fill in the gaps. But equations of straight lines are really important because every straight line is defined by its equation. So pretty much everything you'll do in the future with straight lines is going to be defined by the equation of a straight line. So being able to work with the equations, being able to find the equation of a straight line is a really core skill in this topic. So in general, the equation of a straight line looks like y equals mx plus c. In this equation, the m and the c are the gradient and the y-intercept. So the gradient is just the steepness of the line. So basically the angle that the line goes on. So positive gradients go up to the right, negative gradients go down to the right. Lines which are horizontal have got a zero gradient because they've got zero slope. And the c value is the y-intercept. So that's where the line cuts over the y-axis, the vertical axis. So those are the two things that we use to define a line. So in reality, these are going to be numbers, just like in the examples that I've got over here. So what we want to be able to do is two things. We want to be able to look at the equation of a line, and from that equation make either a rough sketch of the line or make a more accurate sketch as the question might dictate. But we also, and probably more importantly, we want to be able to take 2 points that we know are on the line, draw a line between them to see a visual of the line, and then more importantly even than that, to make the equation of the line from these 2 points. So in other words, to turn these numbers, which are just coordinates on the line, into this form of equation. So going from there to there is probably the core key skill in this topic. So we'll start with these ones, which are just kind of to get orientated. So if we look at this first one here, y equals 2x plus 1. So this guy here, the 2 is the gradient, and this guy here, plus 1. So keep an eye on the sign there, is the y-intercept. So if we wanted to draw a sketch of this graph, then we just fire up an xy axis. Start by marking on the y-intercept. So it's only 1, so it's not very high up, so maybe somewhere like there. A gradient of 2. At this point, you maybe don't quite know how to judge the steepness based on the gradient number, but if it's positive, then it's sloping up to the right. Generally, they're roughly around 45 degrees, so a gradient of 1 is exactly 45 degrees. A gradient of 2 is a little more than 45. Anything less than 1, like 0.5, is a little less than 45, but it doesn't double. So if you go from a gradient of 1 to a gradient of 2, it doesn't go from 45 degrees, which is a gradient of 1, to 90 degrees. It just incrementally changes. So gradients tend to be roughly between 0.5 and 2, 3, 4, something like that. It's unusual to see gradients in questions higher than that, but they could be anything. You could have a gradient of 25, and that would just be some really, really steep line. This one, gradient of 2, is roughly 45 degrees. So just as a sketch, our line would go something like that. And quite often in these questions, we're just trying to get a sketch. We're not necessarily trying to draw a perfect graph. So taking a look at this guy and doing the same thing. Slightly different scenario. We've got a negative gradient and a negative y-intercept. So the gradient is -1. The y-intercept is -4. So we'll mark on the y-intercept again first. So let's say that's down like there somewhere. Gradient is -1, so that's 45 degrees, but in the opposite direction. So a 45 degree line going down the way because the slope, the gradient is negative. So that gets us orientated. So notice that with these two, if we had, say, points on the line, if we knew the coordinates of those points, like maybe a couple of points down here, then there must be some correlation between those points and the slope of the line, because the slope is taking the line through those points, and ultimately also to the y-intercept. So we're going to turn our attention now to how do we take points and then turn them into the equation of the line. So I'm kind of assuming at this point that you've already seen the gradient class where we figure out how to make the gradient based on these. So if not, then maybe just follow along. I'm not going to fill in the details. You can go and fill them in that class later, or just maybe stop at this point and check that out and then come back in here. So in these questions, we're going to start by making the gradient. So if you're not quite sure what I'm doing, then yeah, check that out. But basically, we start by labeling these, x1, y1, and x2, y2. There's a little equation to make the gradient, and we're going to say that it's the vertical over the horizontal, or in the other case, it's y2 minus y1 divided by x2 minus x1. We're going to label this m for gradient. That's a standard letter for a gradient. That's the one we use in the equation. So y2 minus y1, that's 10 minus 4. So 10 minus 4 divided by x2, which is 4, minus x1, which is 2. Process that all the way through. Usually comes out to be a whole number, but it could be a fraction or a decimal. So 10 minus 4 is 6, 4 minus 2 is 2, so that one comes out to be 3. So what we're going to do at this point is maybe just draw a quick sketch to get orientated. We're not quite finished yet, but this will help to make sure that the answer kind of makes sense. So we've got these 2 points, so 2, 4, and then 4, 10. So 2, 4 might be like there, 4, 10 is like up there. This is just very, very rough. So I reckon the line probably goes something like that. So we can see it's quite steep, which would be reflected in the positive and slightly higher gradient. So that looks good at this point. We've got a gradient that makes sense. All we've got to do now to make the equation of the line is to find that point there, the y-intercept. That's the other thing that defines a line. So the ultimate equation format we're looking for is y equals mx plus c. So there's a couple of ways we can take this forward. I'll show one way in this question, I'll show a different way in this one. But one way you can do it is just to plug in your gradient, because we now know the m value is 3. That's the steepness of the line. So y equals 3x plus c. The c value is the y-intercept, that's what we're trying to find. One way you can do this, take one of your points, doesn't matter which one, either one's fine. I'll take the one with the smaller numbers, put that number in for x and put that number in for y. So we're substituting those numbers in. So we're putting the 4 in the place of y, we're putting the 2 in the place of x, so 3x, remember, means 3 times x, so it's going to be 3 times 2 plus c. 3 times 2 is 6, so just processing this like an equation, just in a little equation basically to solve now, and that would tell you then that your c value is minus 2. So at that point we can go back to the equation and just fill in that c value to get y equals 3x minus 2, which is the final answer. Now, if we turn to my sketch, which remember was just a very quick sketch, but I did it accurately enough. I gave it just enough attention to see that the line cuts just below the point 0, 0. So this y-intercept of minus 2 fits in with the geometry. If my sketch looked like that and the y-intercept came out to be like plus 10, which would be like way up there, then clearly something's not quite tallied up. So that's the benefit, the beauty of drawing a quick sketch. Okay, cool, right, so let's work through the next example. So we're just going to start by doing the same thing, making our gradient. We always start these pretty much by making the gradient. So good practice just to label, oh, that should be a 1, just to label up your points, just to help keep you straight, and then just plugging those into the sort of gradient formula. So we get y2, which is minus 12, minus y1, over x2, which is 5, minus minus 1. So be careful with the double negative there. So minus 12 minus 3 is minus 15. This is 5 plus 1, which is 6. So not come out to be a whole number this time. These are both divisible by 3, so we could simplify it down a little, just dividing top and bottom by 3 to make it minus 5 over 2. You could, if you wish, change that to a decimal, so minus 2.5. I would say in terms of the algebra we need to do later on, probably keep it as a fraction. In terms of figuring out the steepness of the line, it might be more useful to have it as a decimal. So I'm just going to clear a little space here. So again, we're just going to fire up a quick sketch, just really to get orientated. It's not usually part of the the question. It's not usually a requirement for you to do this, but it is quite valuable. So marking on our points again reasonably accurately. Try and keep orientated as to where your points are going to be. So this point is a lot bigger than the others, so kind of make space for that. So -1, 3 is like up here somewhere, and then 5 minus 12 would be like maybe way down there. So our line is going to go through those points, something like that. So we can clearly see that we've got a steep-ish negative gradient, which fits in perfectly with the number that we got there. This one, the y-intercept looks to be really close to 0. It's unlikely to be right on 0. It could be if my sketch is really accurate, but I would say that just imagine it being somewhere around there. So we know that it should come out to be a low value for the C value. If it comes out to be like a big number way up here or some value way down there, it's worth checking because something doesn't seem to be quite right there. So for this one, we're going to use a slightly different form of equation. So you can use this method to get the final equation. You can also use a method using an equation which says y minus b equals mx minus a. So what is that one all about? Well, for this one, we're going to plug in the m value, which we've already got here, and we're going to also plug in an AB value. AB value is just one of the points on the line. Doesn't matter which one you choose. I'm going to nominate my first point again. So make this the A value, make this the B value. So this is just a different form, which you'll probably see, of getting to this final equation just by a slightly different means. So all we're going to do then is plug in the value. So the B value is 3. So we get y minus 3. The m value, we could use either of these. I'm going to use the fraction version, so minus 5 over 2 x minus the a value, which was -1. So we're going to get a double negative there, so it'll be minus 1 or plus 1. Okay, so I'm just going to move my working up here. So keeping an eye on our diagram just to make sure that the final answer kind of tallies in with that. So I'm just going to pull that up here to make a bit of space. You could deal with this in slightly different ways. I think we'll just multiply the bracket. So we get y minus 3 equals minus 5 over 2x minus 5 over 2. The other way to deal with it would be to multiply everything by 2 at this point to get rid of the fraction. That's really personal preference. It depends how you kind of want to proceed with that. And then we're just going to try and put it in the correct format. So y equals the m value x and then minus 5 over 2 plus 3, which I've got by moving that 3 over. And then all of this here is your c value. Let's just tidy that up a little so we can check what the actual value is. So a little bit awkward this one with fractions. It's not uncommon to get fractions in these questions though. So let's just imagine that 3 to be written as 6 over 2, so we can combine it with the other fraction. So that's going to be minus 5 over 2 plus 6 over 2, giving us a final answer of minus 5 over 2x. These guys would add together to be 1 over 2. So that's minus 5 plus 6, which is 1 over 2. So 1 over 2, 1/2, pretty small number. So that's why the line looked like it was going through 0 or very close to 0. So a little bit more difficult, that example. Just bear in mind that you've got the option to either use this form, even though that form will eventually take you back to the other form, which should look like y equals mx plus c. So we say that y equals mx plus c is the format of a straight line equation. This is not the format of a straight line equation. This is just a format that allows you to get there by taking a point on the line like this and taking the gradient and plugging them in. Or you can do it the way that we did it in the first example, just by plugging them in directly. No real difference. Well, there is a difference. There's no real benefit to one or the other. They're pretty similar techniques. So that's basically how you go about finding the equation of a straight line. Like the gradient, the requirement is to have 2 points. 2 points defines a line, because if you've got 2 points on a line, then you can draw the line through them, and that's all you need. You don't need 3 points. 1 point's not enough, so 2 points is pretty much the standard question type in this topic. The key skill that you need to learn is how to take any 2 points on a line and quite quickly, quite efficiently do what I did there and make the final equations. That's a core skill. You're going to have to do that millions of times. So you're going to get plenty of practice on this topic. It's a good one to be good at. It's a really common exam question in a whole bunch of classes right the way up through. So calculus classes, these will still be kicking around even once you've moved on to more complex functions. So this is one to pay particular attention to. So maybe go through this a couple of times, make sure everything I've said there makes sense. Definitely check out a whole bunch of practice questions on this topic.